Wow, what a change in the weather. I think we're going to hit a high of about 63 today, where we've been up in the mid-80s, but about a month ago we were in the mid-90s, so this is really a welcome relief for me. I'm going to start talking about compound pulley systems today, and I'm first going to show you what one looks like. And I have two 2-to-1 independent pulley systems here, and I have a weight on one. If we pull here, the weight comes up and it takes half the force here of the weight, and I don't have anything hooked up to this one, but I'm going to use it to show you how a compound system works. What if we just hook the load up to these two independent pulleys so that they equally share the load? Well, we can see that we'd have 1, 2, 3, 4 supporting lines, and these are simple pulley systems, so it would appear we have a 2, 3, 4 to 1 ratio. This is not doubling or anything, it's just balancing out the load. But the reality is that's not what we have. If we consider that we've got a fourth of the load here and a fourth of the load here, we're having to supply a fourth of the load here and a fourth of the load here. Added together, they're half of the load. So half is still 2-to-1. So even by adding a second pulley system, we still only get a 2-to-1 from 2-to-1. So that method doesn't work. So we can't just keep putting them up and hooking them to the load and hoping they'll share weight. They won't. But there is something we can do, and I'm going to show you that now. Well, we just looked at one method that doesn't work. Just doubling up on the pulley systems to the load doesn't work. So let me show you what I've done next. While I was gone, I disconnected this from up here, and I've run it through the pulley the same way, but I've let the pull line of this pulley be the load for this pulley. This pulley is anchored here, and it comes up here, and this is just to hold it in place so it won't fall. So my pull line is really right here. Now what we have now is a simple pulley system working on the pull line of another simple pulley system. That's a compound pulley system. So when I pull on this rope, notice how much faster this one's moving up than this one. You saw this before when I was talking about simple pulley systems, and the fact that in a simple system each pulley that moves has to move toward the anchor at the same rate of speed. Well, these obviously aren't at the same rate of speed, and we have one pull line serving as a load of the next. Now if we look at this, we can't do the rope counting thing. The most accurate way, I think, to analyze this is by the T method. And the T method, just in quick review, is you take the tension on the pull line and see how it feeds through the system and see how it acts at the pulleys and all the way through to the load. So let's do that. I've been using 1 pound for this, and we look to see what that 1 pound does. Here I'm going to use just the letter T, and it means tension in the rope, and it equates to force in the rope. So if I have T pulling in this rope, a force of T, it goes through here, and I also have T right here. So 1T plus another T is 2T right here. That's that pulley principle. So I have 2T pulling at this point. So it goes through the pulley system, and it has 2T over here also. So 2T plus 2T is 4T right here. So with only 2 pulleys, we get a 4-to-1. And this is a compound pulley system. Now let's define what a compound pulley system is. A compound pulley system is any arrangement of simple pulley systems working on another simple pulley system. And that's what we have here. We have a 2-to-1 here working on another 2-to-1. And one of the neat characteristics of that is that you can take the 2-to-1 that we have here, which is a simple pulley system, and the 2-to-1 that we have here, and just multiply the mechanical advantage together, and that'll give us the total thing. So if I know this is 2-to-1, and I know this is 2-to-1, the total system is going to give me a 4-to-1. If I had a 2-to-1 here, and I know it's a 2 to 1, and I make this one a 3 to 1. 3 to 1 times 2 to 1 is 6. So that's one of the nice characteristics. Another part of the definition of a compound pulley system is that, like a simple pulley system, the pulleys that move have to move toward the anchor. But in a compound system, they don't have to move at the same rate of speed, and we can see they don't. This one moves a lot faster than this one, but they both are still moving toward the anchor. So this is just one simple form of a compound system. If we were to add a second pulley, just like this, just kind of expand it, we would start to see a base 2 exponential increase in power. For example, 2 raised to the 1, 2 pulleys is 4. This is a 4 to 1. If we added another pulley and a 2 to 1, it'd be 1, 2, 3. 2 raised to the third power is 8. So it'd be an 8 to 1. If we added one more pulley so that we have 4 pulleys all arranged like this, it'd be 2 to the 1, 2, 3, 4, which is 16. So it'd be a 16 to 1. You can't see it in this one because it looks the same. 1, 2, 3, 4 lines supporting the load. Looks like you can count lines and do it, but you can't. If I were to add that third pulley, we would get 6 lines supporting the load, but it would be an 8 to 1. So in a compound, anything in fact that's not a simple pulley system per se, all the way through the system, you cannot count ropes and get a reliable answer for the mechanical advantage. And we're going to look at another variation of this. I've used 2 ropes. Notice the blue rope and the red rope. I'm going to do it with just the red rope next.